Alright, 7.6 notes. Proving quadrilaterals on the coordinate plane. So basically, looking at a graphed figure and proving it's quadrilateral. So, these are how you can prove in different manners. If you prove both pairs of opposite sides are congruent, you could do the distance formula on all four sides. It would be a parallelogram. If you prove both pairs of opposite sides parallel, do the slope 4 times. The diagonals bisect each other, so you find both midpoints. One pair of opposite sides is parallel and congruent, distance and slope. So those are your choices for proving something to be a parallelogram. It depends on what formula you like. So number 1, if you want to crank out the distance formula 4 times. Yeah, number 2, you want to crank out the slope 4 times. Or number 4, maybe you just want to do one of each on 2 opposite sides. It's up to you. So here are the formulas we're going to be using. Slope formula, distance formula, and midpoint formula. So prove that this is a parallelogram. So 2, 3 is A. B is at 8, 4. Almost on the chart, but it's not. C is at 7, negative 2. And D is at 1, negative 3. Always better, of course, if you use a straight edge. Is it a parallelogram? Maybe. Looks kind of like it. But let's see. Now, at this point, you can choose whatever you want to do. Again, you can find the slope on all 4 sides. And you can do that mathematically, or if it's graphed, you can actually just count the slope. Okay, so remember the slope is the change in y over the change in x. That's not supposed to be a plus. So you can actually do that 4 times and find the slope of AB, BC, CD, and AD. Mathematically, you can do that. But the other nice thing is, when you have the points on the graph, you can save time and just count the slope. So you can do the slope of AB, the slope of BC, the slope of CD, and the slope of AD, or DA, however you want to look at it. So AB, I go up, down, then left, right. So from A, up 1, so that's up 1, positive 1, right, 1, 2, 3, 4, 5, 6. So that has a slope of 1/6. Now from B to C, I can start here at B. I'm going to go down 1, 2, 3, 4, 5, 6. So down 6 and left 1, left being negative. So that's the same as 6 over 1, or just 6. CD. From C, I have to go down 1. So again, that's negative. And then go left 1, 2, 3, 4, 5, 6. Left 6, which again is 1/6. And hey, that matches. So those opposite sides are parallel. And I can mark it right now, parallel. And now DA, I go 1, 2, 3, 4, 5, 6, up 6, right 1, 6. These two are parallel. So I can mark this, those two parallel. Which, again, was one of my options. both pairs of opposite sides parallel. Number 2, I've just proven this to be a parallelogram. That's one way to do it. And yes, it's going to be repetitive because I'm going to show you different options. You get to choose when you're doing this on your own. You don't have to do all ways. Okay? Now, let's say I wanted to do one pair of sides just parallel and congruent. Let's say AB and CD. So I've already found the slope. Now what I would do is I would do the distance formula. And again, the distance formula is the square root of x minus x squared plus y minus y squared. All right? So, if I was going to do AB, and I'm going to do CD, I look at my points for AB. Okay? So the points for AB, again, are 2, 3, and A4. So I would do, for AB, 2 minus 8. If you want to do 8 minus 2, that's fine. It'll all work out. Plus 3 minus 4. Again, if you did 4 minus 3, these would both be negative. But it's not going to matter because when you square them, they become positive. So 2 minus 8 is negative 6. Squared is 36. Plus 3 minus 4 is negative 1. Squared is 1. So this works out to be the square root of 37. And you can just leave it there. You don't need the decimal. You can leave it. We're going to see if we get CD as the same thing. So for CD, it'd be 7 minus 1 squared plus, careful here, negative 2 minus a negative 3 squared. At this point, it's plus. So 7 minus 1 is 6. Squared is 36. Looking good. 3 minus 2 is 1. Squared is 1. I have the square root of 37. I'm good to go. So what I've just proven now is that AB and CD are congruent. So another option again would be I could have just found the AB slope and the CD slope and then done the distance formula, and that would have been good enough to prove this to be a parallelogram. Also, I could have done all 4 distance formulas only, and that would have proven it. So there's a lot of options here is what I'm trying to get at. All right, steps in coordinate proofs. First, graph quadrilateral. Consider what you think it will be. Do you think it's a rectangle, a square, a rhombus, a kite? Then use the slope, midpoint, and our distance formulas to determine its classification. That's what we just did. Then write a concluding statement to justify your classification. So that's what we did not do. So I'm going to come back here and write ABCD is a, and you can abbreviate here, parallelogram, because and then here's where you fill in the blanks. You could say both pairs of opposite sides have the same slope. Or if you went the other route, you could say because one pair of opposite sides is congruent with the same slope. So, depending on which way you prove it, that would be a concluding statement. And again, you don't have to do more than one way, just showing you some options. All right, rectangle. To prove it's a rectangle, first you have to prove it's a parallelogram. So you have to do what we just did, one of those 4 options. Then you have to go one step further and prove that the diagonals are congruent, or one set of consecutive sides are perpendicular. I personally like this one. Whoa. I personally like this one just because, you can count the slope and you're done. And the nice thing is, since one of the ways to prove a parallelogram is just do all four slopes, if you do all four slopes, you'll prove that it's a parallelogram, and then looking at the slopes, you can prove it's a rectangle in one fell swoop. So that's just kind of a shortcut. For a rhombus, you have to show that it's a parallelogram, like at the beginning, and then the diagonals are perpendicular, or one set of consecutive sides is congruent. So that would be the distance formula there. Your choice. To show a square, you have to prove it's a rhombus and a rectangle. So again, you have to prove rhombus, then you have to prove rectangle, which, like I said, if you just did all four slopes, you could do that all at once. And then all sides are congruent, and one set of sides is perpendicular, which, again, if you did the four slopes, this would already be done, and you just have to do the distance formula on all four sides. Or the diagonals prove congruent and perpendicular. So square obviously takes the most proof because it's the most specific shape. So let's do this. -5, 3. -5, 1, 2, 3 is P. And then 1, -1 is Q. -1, -4 is R. Whoop, that's a B. R. And S is -7, 0. All right. Looks like a rectangle to me, but you cannot go by looks alone. So we have to do the math. Again, I think it's easier myself personally. What I like to do is just do the slope because I can count it. Of course, I could do the y minus y over x minus x, but I can just count. So I'm going to do the slope of PQ. I'm going to do the slope of QR. I'm going to do the slope of RS. And I'm going to do the slope of S back to P. Again, you can say PS, doesn't matter. So PQ. Well, starting at P, I'm going to go down 1, 2, 3, 4. So down 4, that's -4. Over 1, 2, 3, 4, 5, 6, over 6. Positive 6, so I went right. Well, that reduces to -2/3. QR, I go down 1, 2, 3, so down 3, and left 1, 2. That's -2. That is 3/2. Well, what do you notice? These two right here are reciprocals, and they're opposite reciprocals. So that means that these two are perpendicular because they're opposite reciprocals. So that's good to know. We need that to be for a rectangle. So RS. For RS, I'm going to start at R, go 1, 2, 3, 4, up 4, it's a positive 4, and left 1, 2, 3, 4, 5, sorry, you can go far enough, 1, 2, 3, 4, 5, 6, left 6, that gives me -2/3. Well, that means these two are parallel. And then for SP, I'm going to go 1, 2, 3, up 3, and right 2. So these two are parallel. So I've proven this side and this side parallel. I've proven this side and this side parallel. I've also proven these two sides to be perpendicular. These two sides, these two sides, these two sides. So I've now proven a rectangle. ABCD is a rhombus, right? So -1, 0, 4, 0, 3, 3, 8, 3, A, B, C, D. All right, so to prove a rhombus, remember, we have to prove first off that it is a parallelogram. So again, I find it easier just to go right off the bat, prove the slopes. That's easiest way. So M of AB, M of BC, M of CD, and M of D back to A. The nice thing is, if you look at CD and AB, they're flat, they're horizontal. That is a slope of 0. So right off the bat, I know CD and AB are congruent, and they're both 0. So right off the bat, I can mark these congruent. Now I'm going to do AB and CD. Starting at A, B, and CD. Did I mark those right? Yeah, I did. So I'm going to do BC. Can't do BC. What did I do wrong? Let me see what you're at. Right. -1, 0, B is 4, 0. So it goes A, B, D, C. So I can do AB, and then this should be BD, sorry. And this should be CA, not DA. My bad. Okay, so BD, starting at B or D, doesn't matter. From B, I go up 1, 2, 3. So up 3, that's positive. And right, 1, 2, 3, 4. Positive. From C, I go down 3, 1, 2, 3. That's -3. And I go left, 1, 2, 3, 4. That's -4. But that's the same as 3/4. So B, D, and CA are also parallel. As soon as I do that, I've proven that this is a parallelogram. So I'm good to go on that part. All right? So I have a parallelogram. Now I have to do one of two things. I have to either prove the diagonals are perpendicular, or I have to prove that one set of consecutive sides are congruent. So I have a choice here. I could do distance formula on two sides, or I could put in my diagonals, like so, and do the slope of those two diagonals, and see if they're perpendicular. That's a pretty easy thing to do, so I'm going to do that. I'm going to show you another trick. Okay, so I do need CB now, because that is a diagonal. And from C, I'm going to go down 1, 2, 3, and right 1. And from A to D, I'm going to go from A up 1, 2, 3, up 3. I'm doing AD here. Up 3. Right 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that reduces to 1/3. -3 over 1 and 1/3 are perpendicular. So I have proven that this is rhombus. But there is a shortcut here. Now this doesn't always work, but if you ever have two sides that are horizontal or vertical, the distance is very easy because you just have to count. So if I wanted to count the distance, and I'm going to say CD, and the distance of AB, because they're both horizontal lines, watch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, again, it's not saying you couldn't do the distance formula, or you couldn't have done the distance formula AC and BD, but when you have possible shortcuts, take them. It just makes life easier. So now, I have all the information I need. So I can say that ABCD, wow, ABCD is a rhombus because, again, I proved both sets of parallel sides, or both opposite sides, are, oh, I should have said have the same slope, sorry. And I have a couple options here. I could say the diagonals are perpendicular, or I could say one pair of opposite sides are congruent. So again, it doesn't have to be that long. You just pick one of those two ways. It depends on what you did. There we go.